Hello everyone, my name is Suvrat and I'll be discussing AtCoder Beginner Contest 438 today. Let's start the discussion. The first problem is first contest of the year. Problem statement: on a certain planet, a year has d days and contests are held every 7 days. Contests never span across days. The first contest of a certain year was held on the fth day of that year. On what day of the next year will the first contest of the next year be held? The constraints of this problem guarantee that at least one contest will be held in the next year. And the constraint given are D is from 10 till 366 and F is from 1 till 7. So basically the problem is that we are given problem A. We are given D, which is the number of days in a year, and we are also given F, which is the day on which first contest was held. And we need to find the day of first contest in the next year. So let's see the test cases. Also the constraints would be for D, they are from 10 till 366, and for F it is from 1 till 7, and also contests happen every 7 days. So let's see the test cases. First test case is 365.4. So we can see that the first contest will happen on the 4th day, then the next would happen on the 4 plus 7th day, then the next would happen on 4 plus 14th day, and so on. So 4 plus 357, 350 is a multiple of 7, right? So 4 plus 350 would be a day, and after that 4 plus 357 will come, and after that 4 plus 364 will come. So 4 plus 364 is the 368th day, which is in the next year, because the year was of only 365 days, and this is 361, which will be in this year only, because this year is still 365th day. So the next contest will happen on the 3rd day of the next year. So the answer for this test case will be 3. Then the next test case is 10 and 5. So D is equal to 10, F is equal to 5. So the first contest is held on day 5. Then the next is held on days 5 plus 7, which is 12. 12 means that the next year has started. So the answer will be 2nd day of the next year. So the solution to this problem is quite the same that we are doing to solve the test cases. What we'll be doing is while our F is less than D, we can just add 7 in our F, less than equal to D actually. So we will just add 7 in our F, and then once we are in the next year, F minus D would be the answer. So we'll be just doing this, and since F and D are both very small, this will easily fit within the time limit. So this is the solution. I'll show you guys the code. Problem A. So we'll just take input D and F, and we'll just increment F till in my code I've done F plus 7 less than equal to T, So that is the same. If I remove this from here, this while loop will iterate one more time. So and then answer would be f plus 7 minus d. It's the same. So this problem was quite brute force. Now let's see the next problem. So you are given integers n and m and a digit string s of length n and a digit string t of length m. Here a digit string is a string consisting of digits from 0 to 9. You can perform the following operation 0 or more times. Choose the character from t and increase the chosen digit by 1. However, if the chosen digit is 9, change it to 0. Find the minimum number of operations required to make t a substring of s. And the constraints we are given are m and n are less than 100. So the complexity could be n square m or even more actually, because we can run 1e8 operations in 1 second, right? So the constraints are pretty small. So problem B. So we are given n, m, s and t. So basically string s and t consists of digit strings actually. So what does digit string means? It means that si is from 0 till 9 and similarly ti is also from 0 till 9. And we can do this operation. In one operation, what we can do is we can make ti plus equal to 1, and if ti becomes 10, then we change it to 0. So basically what we are doing is we can increment the value of ti from 0, 1, 2, 3 such that till 9 and then again 0. So this is the operation that we can do. So what we need to tell is minimum number of operations such that t becomes a substring of s. So let's see the test cases. The first test case is 202591. So 2025 and 91. So what are the possible outcomes? So in 2025 we have 1, 2 and 3 different substrings that of size 2. So we can either change this substring to 91, or we can change this substring to 91, or we can change this substring to 91, and we need to see which of the which one would be the easiest to make in terms of the number of operations. So let's try to make this substring. So 91. So first we'll have to make 9 as 2 and then we'll have to make 1 as 0. So to make 9 as 2, we need, in one operation 9 will become 0, and in another operation it will become 1, and in another operation it will become 2. So 3 operations on 9, and on 1 I think 9 operations on 1. 2, then 3, and so on till 0 would take 9 operations here. So 9 operations on 1. So this will take 12 operations. So this is 12. Now let's see how many operations will 0 to take. So 9 will take 1 operation and 1 will also take 1 operation. So 2 operations. And 25. So 1 will take 4 operations, 9 will take 3 operations, so 7. And the minimum of these 3 would be 2. So the answer is 2. The next test case, since 38 is already a substring of s, then the answer is 0 since we don't need to perform any operations. Then the next test case is 0, 0, 0, 0, 0 and 1, 1, 1, 1, 1. So since they are of the same size, we don't have any choice and we will have to transform this whole array t into this whole array s, whole string s. So each one will take 9 operations. Since from 1 we'll have to make it 0, so that would be 9 into 5, which is 45. So the answer of this test case is 45. And similarly we can brute force on the last test case also. So since the constraints are small enough, since they are just 100 n and m are till 100, so we can brute force as well for the solution also. So how will the brute force look like? Just like how we were doing manually. So from I equal to 0, I less than n, and I plus plus. So what this I will tell us is that we are currently calculating the answer for the I till I plus m minus 1 string to convert our T string into this substring of S. So that answer, and we will just globally declare our answer as a large number since we need to minimize the operations. And what we can do is for j is equal to 0, j less than m, j plus plus, and then what we can do is ops to make T of j S of I plus j. That operations we can just take sum here. Actually let me do it like this: current plus equal to, and we'll define a current here which stores the current answer for this case, and then we can just take the minima for our global answer. So running these two for loops will ensure that every possible substring in S is checked for corresponding to T. So every substring will be checked, hence our answer would be correct. And this is just like the test cases. This is the brute force solution again. And the complexity would be, since we have two for loops, it will be n into m. And even if we do the operations by brute force, again it will take a maximum of 10 operations to convert this digit into this digit, since there are only 10 digits. So n into 10 at max. So that would be the time complexity. I'll show you guys the code. So we take input nm and then string st. Then I declare answer as a large number, and then I run those two for loops. Also we need to check I plus m should be less than or equal to m, otherwise this would go out of bounds. This should not go out of bounds. This should be less than or equal to n minus 1. And what we can do is just take out the character in the S string and take out the digit in the T string, and then we can simply brute force the number of operations as well till T is not equal to S. We can just keep on incrementing the value of T, and once T becomes 10 we can make it value 0, just as it was stated in the problem statement. And we'll just keep the count of how many times we need to increment the value of T, and that would be the number of operations to make Ti as Si plus j. And then we'll just increment that, add that value to the current answer, and global answer would be the minimum of answer and current answer, and then Cout answer. So that was the solution for problem B. Let's move on to problem C. So in problem C, you are given an integer sequence A is equal to a1, a2, a3 till an of length n. You can perform the following operations 0 or more times in any order. Choose an integer k between 1 and a minus 3 inclusive, such that ak is equal to ak plus 1 is equal to ak plus 2 is equal to ak plus 3, and remove ak plus 1, ak plus 2 and ak plus 3 from a. More formally, replace a with we have removed these four terms and just concatenated the arrays from a till a1 till ak minus 1 and ak plus 4 till an. Here mod a represents the length of the integer sequence a. Find the minimum possible value of final a after repeating the operation. So problem C. Yeah, so problem C. We are given array A of length n, and basically the operations that we can perform is for a given k, ak equal to, if for some k, actually that would be better, for some k, if ak is equal to ak plus 1 is equal to ak plus 2 is equal to ak plus 3, then we can remove ak plus 1, ak plus 2 and ak plus 3 from the array. Also, the indices would be readjusted after we remove these 4 elements. That is basically a1, a2 till an would be the array initially, and then a1, a2, ak minus 1, ak plus 1, ak plus 4, ak plus 5 till an. So this would be after removing, and then the indices would be rearranged, and this array would once again become a1 till a sum m, which is actually n minus 4, I think. Yes. So these indices would change like this, and then again we can perform this operation again. So let's see the test cases. So 1 1 1 4 4 4 4 1 2 3 4 4 4 4 and 1 2 3. So basically we can see a 4 4 4 4 here. So what we can do is we can remove out this subarray, and then the new array would become 1 1 1 1 2 3, and then again we have these 4, so we can remove out these, and then the answer would be 2 3. Then the next is 2 1 3. Since there are no elements same, then the answer is simply 3. We cannot perform any operations on this since there are no 4 consecutive elements that are same. Then this 1 1 4 4 4 1 1 1 1 4 1 4 1 1 1 1 1 4 1 4 1. Okay, so again we can see these 1 1 1 1 here, so we can remove out them. So the array will become 1 1 1 4 4 4 4 1 4 1. Then we can see that these 4 are being removed out. So 1 1 1 4 1 will be the new array, and we cannot perform any more operations. So the answer for this would be 5. So basically in this problem what we need to do is we need to find consecutive 4 elements that are same and keep on doing so till it's possible, and then the remaining array would be the answer, and then remaining array size would be the answer. So basically if we try to solve this naively, what we can do is we can again and again run a for loop for I is equal to 0. What we can do is basically let's say that we have some array 1 1 1 1 1 1 1 4 4 4 1, and then 2 2 2 2 and 3 3 3 3. So what we can do is we can run a for loop in O of n to identify if there is any, actually 4 1. So in O of n we can run a for loop like this. This is the first approach that comes to your mind, the naive approach. So we can just run a for loop like this, and we can just check if a of I is equal to a of I plus 1, which is equal to I plus 2 and equal to I plus 3. So if we find these 4 elements which are same, so what we can do is we can just erase the 4 indices from array A and we can rerun the for loop simply. So what would be the time complexity of this naive algorithm? So what this naive algorithm will do is, in O of n we will identify this 4 4 4 4 and then remove from this array, and then in the next iteration we will identify these 1 1 1 1, which will again take an O of n iteration and will remove these 4, and in the next iteration we will identify these 2 2 2 2, which is again an O of n, and in the next iteration we will identify these 3 3 3 3, which is again an O of n. So basically this algorithm is O of n square complexity, since we would have to use, since we will be iterating over the array once again after removing some consecutive 4 elements. So and only 4 elements would be removed per operation, so there can be an O of n order of operations. So if each operation takes O of n complexity, then the total complexity this naive approach would require is O of n square, which will not work since n we are given is still 2e5, and the maximum time complexity that you can use is O of n or O of n log n at max. So we need to try to optimize this. So what we can do is let's take this example only and let's try to see what we can do. So let me write it again. So we had 4 4 4 4 and then we had 1 1 1, I think, whatever, let's just take 2 2 2 2 and then 3 3 3 3. So let's take this array. So the first element is this, and we see that 3 3 3 since there aren't 4 3 consecutive, so we can't do anything yet. Then the next is 2, so again the next is 2, so we still can't do any operation yet. Then the next is 1 and we still can't do any operation yet. So when we come at this point, we realize that these 4 elements are same, so we can do operation. So what we can do is, when we come to these, we can remove these 4 from the array and then continue forward, and then the next element will have 1, then again 1, then again 1, and at this point you will realize that the last 4 again have become the same, so we can remove these 4, and then again 2 2, and then we realize that these 2 again have become the same, so we can cut out these 2, and then we can move forward. So basically this kind of approaches are similar to the good bracket sequence problem. That's where you get the intuition for this optimization. So basically, what is good bracket sequence problem? So we are given some bracket sequence and we need to tell if it's a good bracket sequence or not. So how do we tell if it's a good bracket sequence? So basically, if at all the points if for every close bracket there is a open bracket before it. So that is this problem, and we need to check if this is true or not. So to solve this problem, it is a well-known solution that we just run from left to right. So we have one open bracket, then we have another open bracket, then we have another open bracket, then we have another open bracket, and then we find our first close bracket. So what we can do is we can just remove this open bracket with this close bracket. Then we move forward and we again find this open bracket, which we can use to remove this close bracket. And then we again find this open bracket, close bracket actually, and we use this to remove this open bracket. Then we move forward and we have another close bracket, so we just take it. Sorry, actually I am confusing with open and close. So again we find an open bracket, we just take it, and then the next close bracket that comes, we use it to cancel this out. And then again in the end there is another close bracket, so we use it to cancel this out. So basically we ensure that there are no left opened or closed, no brackets left, and every close bracket had an corresponding open bracket. So this bracket sequence was good. So we can apply the same type of logic to this problem. So what we can do is for a given array like this 3 3 3 1 1 and let's say 2 2 4 4 4 4 2 2 1 1 3. So what we can do is we can maintain another vector which will be initially empty, and we can just put this 3 here since it is empty, then we can put this 3 here since this is empty, and then we can put this 3 here since it is empty. Then we have 1, then we have 1, then we have 2, then we have 2, then we have 4 4 4. Now an interesting thing happens, just like how we used the close bracket to cut out an open bracket that was before it. So what we can do is when we try to insert this 4 into this array, we realize that the last 4 terms have now become equal. So what we can do is we can use this 4 to cut out these 3 4s. So these 3 4s will be removed. So since the pop function of a vector is O of 1 operation, so we can easily remove these 4s from the vector, and then we can continue forward. So this 2 will come here, and when we try to insert this 2, we see that the last 3 elements are now again the same. So what we can do is we can remove these 4 elements. So these 4 will be removed. And then 1 1, so again 1 1 will be removed, and then 3, so again 3 will be removed. So that's how we can move forward with this problem. So how would it look like in code? So we can just do this, and we can just push that in our vector, and we can check if v of whatever is the current size, let's say m, the current size of v, so we can just v dot pop 4 times. So that would remove the last 4 elements, and after this for loop has ended, our answer would be simply v dot size. So this is O of n algorithm, since each element would be pushed back in v only once and removed only once. So O of n algorithm, and this check would require, if we consider this check as an O of 4 operation, so we can just say that our complexity is O of 4n. So it is again the same. O of n and O of 4n are the same, they are both order of n. So I'll show you guys the code for this. So I take input the vector v, and this is my answer array. So I'll push every element in the answer while iterating over them, and then what I can do is I can check if the last 4 elements of the answer are same or not. Also the answer dot size should be greater than equal to 4 to do that check. So if the last 4 elements are same, I can just remove all of them from answer, and in the end I would be left with an array that doesn't have any 4 same elements. So that would be the minimum size of my array, possible. So answer dot size would be the final answer. So that was the solution for problem C. Let's move on to problem D. So problem D is you are given n integer sequences. A is equal to, you are given length n integer sequences A, B and C. Find the maximum possible value of summation of A from I is equal to 1 till x, summation of B from x plus 1 till y, and summation of C from y plus 1 till n for a pair of integers x comma y satisfying 1 is less than equal to x, which is less than y, which is less than n. And the constraints say that n is less than equal to 3, 5 and ai, bi and ci are less than equal to 10, 1 is 6. So the expected time complexity would be around O of n and O of n log n. Problem D. We are given array A, B, C of size n, and what we need to do is maximize summation of I is equal to 1 till some x ai plus I is equal to 1 from x plus 1 till n bi plus I is equal to till some y plus 1 till n ci, where we are given that 1 is less than equal to x, which is less than y and which is less than n. So we need to maximize out this function. So let's see the test cases for that. 1 4 2 4 3. So 1 4 2 4 3, 2 3 4 2 2, 2 3 4 2 2, 3 2 4 4 3, 3 2 4 4 3. So since we are given that 1 is less than equal to x, right? So x is greater than equal to 1. So at least one element would be taken, at least the first element would be taken from the array A. So we'll take this from here. And then we see that 4 is greater than 3. So what we can do is we can greedily just do this. And then I think we'll move to the array B and then array C. I think this would give the maximum. 4 plus 1 5 plus 4 9 plus 4 13 plus 3 16. Yep. So this is the maximum answer. So answer is 16 in this case, and the summation would look something like this. I is equal to 1 till 2 ai plus I is equal to 3 till 3 bi plus I is equal to 4 till 5 ci. So the values of x is 2 and y is 3. So the value corresponding to x equal to 2 and y equal to 3 is the answer. Then the next test case is 1 1 1, since all the numbers are identical and since we need to respect the constraints upon x and y. Let me just do that, show you guys that as well. So 1 1 1 1 1 1 1 1 1. So the first element has to be from the array A, because I is equal to 1 till x and x is given greater than equal to 1. So first element has to be from array A, and then we can do is what we can do is we need to take the second element from array B actually, because array C also cannot be empty. Since the array C is from y plus 1 till n and y is given less than n, so y plus 1 would be less than equal to n. Hence C array also cannot be empty. There must be at least one element. So for at least one element this should be like this, and also B array also cannot be empty since x is less than y and x plus y would be less than equal to 1. So elements should be taken from B, from B and from C. None of the arrays can be empty. We cannot take 0 elements from any array. So we will choose the boundaries like this. So basically the summation would look like I is equal to 1 till 1 ai plus I is equal to 2 till 2 bi plus I is equal to 3 till 3 Ci, where x is equal to 1 and y is equal to 2. X and y. Okay. In the next test case, 2, 10, 7, 7, 7, 11. 2, 10, 7, 7, 7, 11. 5, 7, 9, 10, 9, 12. 5, 7, 9, 10, 9, 12. 6, 6, 7, 10, 12, 7. 6, 6, 7, 10, 12, 7. N equal to 6. So again the first element has to be from array A, and also we know that the last element has to be from array C. So let's just write this. The first element has to be from array A and the last element from array C. Okay, so the next element, I think it is wiser to take from A, and then we can just do these two, and then I think these two. Okay, so like this 2 plus 10, 12. 12 plus 19 plus 19, so this is 38 plus 12, 50. So yes, so that is the correct answer. So we don't really make any observations apart from this from the test cases. So let's analyze the function and try to see what we can do with it. So we are given this function, I is equal to 1 till x ai plus I is equal to x plus 1 till y bi plus I is equal to y plus 1 till n ci, and we need to maximize this. Also we need to the constraints are 1 is less than equal to x, is less than y, is less than n. So under these constraints we need to try to maximize this function. So what we can do is, clearly it is quite hard to solve a function like this since there are so many summations involved. So what we can do is, to reduce the complexity, we can use prefix sum. That could be one way to approach this problem, since all these three summations could be written in terms of prefix sums pretty easily. So prefix sum of, let's denote pf of a as the prefix sum of a. So p of a till x minus, actually just that, so this would be this, plus this summation would be pf b of y minus pf b of x, plus this would be pfc of n minus pfc of y, and we need to find the value of x comma y such that this is maximum. So let's try to solve this for a bit, and if we are unable to solve, let's see what else we can do. So first of all, this depends on the variable x, this depends on the variable y, this depends on the variable x, and this depends on none of the variables. So this is a constant in our case, in our question, and this depends on the variable y. So what we can do is, we can separate the constant. So pfc of n, this is a constant, and then we can separate the terms that depend on variable x. So pf a of x minus pf b of x, and then we can separate the variable y dependent terms minus pf c of y. So what we can do, since these both depend on variable y, a variable x actually, and these both depend on the variable y. So we what I'll do here is I'll just denote this as p1 of x, and I'll just denote this as p2 of y. So the definition of p1 is, it is simply pf of a minus pf of b, and the definition of p2 is simply, it is pf of b minus pf of c. So now our equation would look like pf c of n plus p1 of x plus p2 of y. So we are clearly seeing that our equation looks a lot more simpler. And again, let me remind you of the constraints. So one was less than equal to x, which was less than y, which was less than n. So let's try to, since this equation is of two variables, right? We have two variables and we need to maximize in respect of both those variables. So what we can do is, another common approach here would be keep one variable constant and try to maximize in respect of other variable. So let's fix the value of x as x naught and try to maximize. So basically what I did here was, my equation was maximum x comma y were the variable, and the equation was pf c n plus p1x plus p2x p2y. So what I did is, maximum x maximum y pf c of n plus p1x plus p1y plus p2y. So I'll be solving this equation and then I'll be finding the maximum for each x, and then out of all those my answer would be the maximum value corresponding to the best x. So the constraints were 1 is less than x, which is less than y, which is less than n. So in order to solve this maximum with respect to y, where x is a constant, so these two values become constant, right? And we need to now just maximize this value. So what would be the maximum value this can attain, since we have this constraint? So this would be nothing but pf c of n plus p1 of x plus maximum y is equal to x plus 1 till n minus 1 p2 of y, and then maximum of this for all x. So now my function looks like this, and so currently if I run a for loop for all the x is equal to 1 till x less than equal to n till actually x less than equal to x can be at max n minus 2. If we see these constraints, y would be at max n minus 1, and since x is less than y, x will be at max n minus 2. So x is less than n minus 2, and if we run this for loop for all x and try to solve this equation naively, we will have to use another for loop from x plus 1 till n minus 1. To find the maximum value of this, we will require another for loop. But what we can do is now to further, since this would be O of n square, right, and 3, 5 was the value of n, so this would be time limit exceeded. So to optimize this, we can pre-calculate this function, pre-calculate the function of y is equal to I till n minus 1, sorry, not summation, maximum of y is equal to I till n minus 1 as p2 of y as some mp2 of y, of I actually. So what we can do is we can do this pre-calculation. So this pre-calculation will be done in O of n prime complexity, because simply mp2 of I is nothing but maximum of mp2 of I minus 1, actually I plus 1, and p2 of I. Since mp2 of I plus 1 is nothing but maximum of y is equal to I plus 1 till n minus 1 p2 of y, and along with this I am including the ith index as well. So taking this max would give me this value. So since this is an O of 1 relation, this whole mp2 array can be calculated in O of n, and then my function, this function, let me cut this from here. So in this function, this term will become simply mp2 of x plus 1. So now what we need to do is maximize pfcn and p1 of n, p1 of x plus mp2 of x plus 1. So we can just run a for loop, and since this is just an array now, and we just need to calculate the maximum of this array, so we can just run a for loop for x is equal to 1 till x less than equal to n, x plus plus x less than equal to n minus 2, x plus plus, and answer would be simply maximum of answer comma this value, and we will just take the maximum of all the values for all the x, and that would be the answer. So say out answer. So this is O of n, and again the pre-calculation is also O of n, and the calculation of p1 and p2 are also O of n, and prefix sums are also O of n. So the whole algorithm would be O of n. I'll show you guys the code. So problem D. So initially we take input the vector ABC. I am doing all the calculations and inputs in one based form. So first I take input ABC, and then I take the prefix sums of A, B and C. I just do it in the same array, and then I create P1 and P2. So P1 would be A minus B and P2 would be B minus C, and then I create that MP2 vector, which would be nothing but a suffix max kind of thing. So mp2 of I is nothing but maximum of mp2 of I plus 1 comma p2 of I, and then to calculate the answer I am doing I am calculating the value of the function at each x and then taking its maximum. That would be our answer. So that was the solution for problem D. Let's move on to problem E. So problem E, there are n people and n buckets. Both the people and buckets are numbered 1, 2 till n. Initially the person I holds only bucket I and bucket I is empty. From now on the following operation will be performed 10 to the power 9 times. For I is equal to 1, 2 till n simultaneously, person I adds I units of water to each of the buckets they are holding and passes those buckets to person AI. There is no limit on the amount of water that can be put in a bucket. For I is equal to 1, 2 till q, answer the following queries. Find the amount of water in bucket Bi immediately after the Tith operation. So the constraints are given as n is less than equal to 2e5, and there are also 2e5 queries. So The time complexity taken to solve each query would be around O of log n. Anything more than that would be TLE. So let me problem D. Just a second. So problem D is basically there are n people, comma n buckets, and bucket I, ith person holds bucket I initially, and what happens is in every operation person I adds I units of water to the buckets they are holding and pass those buckets to the person AI. So what will happen is I will add I units person I units of water to all the buckets he has, and pass all the buckets to AI. So we'll understand this condition more with the help of a test case. So let's see the test case actually. 3 4 4 2 5. So the array A is 3 4 4 2 5, and let me index it also. 1 2 3 4 5 would be the index, and then let's try and solve the first query. So the first query is 4 comma 3. So this is the number of operations or time, and this is the bucket number. So initially the bucket is with the person 3 only, right? Because initially the ith person holds the aith bucket. So let's denote the water in the bucket. We'll write it here in this array. So initially, since the ith person is holding the bucket 3, so they will add 3 liters of water, and that would be the end of the first operation. And then what ith person will do, so the third person will give the bucket to the fourth person, because third person will give the bucket to AI. Person I will add I units of water to all the buckets he has and pass all the buckets to AI. So 3 will add 3 liters of water to the bucket 3 and then pass the bucket to AI, which is 4. So 3 will pass the bucket to 4, and then 4 will add 4 liters of water, and that would be the end of the second operation. And then he will pass the bucket to AI, which is 2. So here, and that would be the end of the second operation. And now since 2 has the bucket, he will add 2 liters of water, and then he will pass the bucket to 4 again, since AI is 4, A2 is 4. So this is the end of the third operation, and then he will pass the bucket to 4, who will add 4 liters of water. So 4, and that would be the end of the fourth operation. So we don't care about who the fourth person again passes to, but just in case he passes to the second person. So after all the 4 operations, the water in bucket 3 would be 3 plus 4 7 plus 2 9 plus 4 13 liters. 11 actually, let me just. So initially the bucket is with person 3, so that is 3 liters. So 3 4, okay, the array is 3 4 2 2 5 actually, sorry about that. So the person 3 will give the bucket to person 2, so this is not 4, this will be 2, and the person 2 will give the bucket to person 4, so this will be 4, and then the person 4 will give the bucket to person 2, so this will be 2, First 3 had the bucket, then 3 gave the bucket to 2, then 2 gave the bucket to 4. So 2 gave the bucket to 4 and then 4 gave the bucket to 2. 4 gave the bucket to 2. This is 5 plus 4, 9 plus 2, 11 liters. 11 liters. Now let's see the next query as well. So the next query is 6.5. So initially the bucket is with the person 5, so we'll add 5 liters of water, and then the person I will pass the bucket to himself only. So he'll just add 5 for all the 6 operations, since he'll keep passing the bucket to himself only. So that would be 1, 2, 3, 4, 5 and 6 operations. So that would be 30 liters. Then the next operation is 1 and 4. So operation is 1 and 4 time bucket. So the water, initially the fourth person has the bucket, so, and since there we need to perform only one operation, so 4 liters would be added and that would be the answer. Then 10, 1. So let's copy this array again. Let's paste it here. Okay. So 10, 1. So first the person 1 will have the bucket 1. He'll pass the bucket to 3. Then 3 will pass the bucket to 2. Then 2 will pass the bucket to 4. Then 4 will pass the bucket to 2. Then again 2 will pass to 4. 4 will pass to 2. 2 will pass to 4. 4 will pass to 2. This is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 2 will pass to 4, 10. So 4, 5, 6, 10, 12, 16, 18, 22, 24 and 28. Yep, 28 liters. And then 10, 2. So again we'll just follow the same pattern. So what happens if we try to naively solve this question? So we will just start with this bucket 1, and what we will do is we will perform 10 operations. First we'll add 1 to our answer, then we'll go to 3, then from 3 we'll go to 2, then from 2 we'll go to 4, and then from 4 we'll go to again 2, then from 2 to 4, and we'll make a T jumps like this. So the overall complexity would be O of T for each query. Since we will be performing T jumps in each query, so O of T per query, we can just naively find which person has the bucket at the end of time T and just take the sum of all of that, and that would be the answer. But what the constraints say that the T is from 1 till 1e9. So O of T per query would be too slow, TLE. So what we can do here? So again, this is related to a very famous problem. So I'll show you guys that problem first. So on the CSCS problem set on graphs algorithms, you have this problem, planet queries 1. So this problem is, you are playing a game consisting of n planets. Each planet has a teleporter to another planet. Just like in our case, each person gives the bucket to another person. So we can just look at this like a teleporter from one planet to another planet. And then your task is to process Q queries of the form: when you begin on planet X and travel through K teleporters, which planet will you reach? So this is not exactly same as the problem we have in AtCoder Contest. So in AtCoder Contest, what we need to do is we need to take the sum of all the K planets that we visit during our journey. But here in CSCS, we just need to tell the last planet. We just need to tell the planet that will be on after the K queries. So this is this is kind of the same question. First I'll tell you the solution for this question, and then we will see how after knowing the solution for this question, will be pretty easily extrapolate that. We can pretty easily extrapolate that solution to this solution, since both of the problems are intuitively the same. Once we understand how this problem is solved, this problem is pretty much the same. So what we have to do is, this problem states that we just need to keep going like this. From 1 we go to 3, then from 3 we go to 2, from 2 we go to 4, from 4 we go to 2, and we just do this 10 times, and we need to tell what is the final planet that we are on. So this is again O of n, right? Naively this is O of n, and again in this problem also there are 2e5 queries, so we cannot do that. So what we can do is, remember, again I'll show you where the intuition for this comes in from. So we have the knowledge of something known as binary exponentiation, right? Binary exponentiation. So let's say that we need to find 3 to the power 7. So instead of naively doing 3 into 3 into 3 7 times, which will take 7 operations, O of 7. So what we can do is, we can, since we know that the binary of 7 is 1 1 1, right? So what we can do is, we can calculate 3 to the power 1 and then square this. So we get 3 to the power 2, and then so we can calculate 3 to the power 1, which is 3, and then we can from this square this. So we get 3 to the power 1 into 3 to the power 1, which is 9, and then we can again square this. So 3 to the power 2 we get, which is 9, and then we can again square this to get 3 to the power 4, which is 81. And we know that this is 7 consists of the bits 1, 2 and 4, all 3 bits. So this can be written as 3 to the power 1 into 3 to the power 2 into 3 to the power 4, and what we can do is, we can just multiply these 3. So this took me only 0 1 2 actually 1 2 3 operations. So you won't understand this in a small number such as 7. What if we had to calculate 3 to the power 81? We would have to perform 81 operations naively, right? But what we could have done is, we can calculate the binary of 81, which is 1 and then 0 and then 0, again 0 1 0 1, I think 1 2 4 8 16 32 64. So 64 plus 16 is 70 80 and 181. Okay, so what we can do is, we can first, we have 3 to the power 1 as 3, then we have 3 to the power as 2 as 9, 3 to the power 4 as 81, and 3 to the power 8, again it would be something. So this is 1, this is 3 to the power 2, 3 to the power 4, 3 to the power 8, 3 to the power 16, 3 to the power 32, 3 to the power 64. So what we need to do is 3 to the power 64 into 3 to the power 16 into 3 to the power 1, right? That's what we need to do, and we get to know these values from the binary, because 64 plus 16 plus 1 is equal to 81, right? So 64 plus 16 plus 1 is equal to 81. So in just 3 to the power 16 would be next, 32 would be next, and 64 would be next. In just 1 2 3 4 5 6 and 7 operations, we would have all these 4 values that are required. So instead of 81, we need to perform such a small number of operations, right? So what we can do is, we can kind of use the same idea here also. First I am talking about this problem, where we just need to find the planet that we would end upon. So what we can do is, we know that if I start from the ith planet, the next planet would be AI, right? We know this. So let me denote this as, let me use some array. So b of 0 of I, let me store this as a of I. So what this means is, I am storing the value for when I start at ith planet, where will I end up at after 2 to the power 0 moves, which is 1 move, actually 1 moves. So if I start from the planet I, after 1 moves I will be at planet AI, right? I know this. So we know this for all I is equal to 1 to n. We know this, we are given this. So now using this, can we calculate where we will end up at b of 1i, which would be from I after 2 to the power 1 moves. So it would be nothing but 2 to the power 0 moves from 2 to the power 0 moves from I, right? So what I am trying to do here is, I will start at I will do 2 to the power 0 moves, I will reach some node, and then I will do again 2 to the power 0 moves, and then I will reach some node. So this is the same as 2 to the power 1 moves, right? So what I am doing is, this is the node where I will end up at after 2 to the power 0 moves from I, and from this node again 2 to the power 0 moves will lead me to this node. So we can use this relation, and we can kind of extrapolate this idea, so that b of j I would be nothing but b of j minus 1 I. So this is some I will show you in a diagram. So I 2 to the power j minus 1 moves leave me to this place, and again 2 to the power j minus 1 moves leave me to this place, and 2 to the power j moves from I is basically the same. So this is 2 to the power j moves, and this is 2 to the power j minus 1 moves, which is this node, and then from this node again 2 to the power j minus 1 moves, so to this node. So what I can so basically I have found a way to calculate b of j comma I from b of j minus 1 comma something. So what I can do is, from smaller values I can fill up the larger values table. So for j is equal to z1 till j is some value like 32, since 2 to the power 32 would be large enough, what we can do is, we can simply do this, b of j minus 1 of b of j minus 1 I is b of j I. So we can just use this relation. We will also run another for loop for I also, and then using these two for loops, what we have now is, from every node we know the answer for 2 to the power some k teleports to other node. So again we can use the idea of binary exponentiation, like say we need to make 24 teleports. So what we can do is, the binary of 24 is 0 0 0 1 0 1, I think. So 1 2 4 8 16 32 oh, actually sorry 1. So what we can do is, we can first make from ith node 16 jumps, and then we will land at some node, and we can make another 8 jumps from there, and then we will land at our answer node. So this would be nothing but b of 4 of I, and let's mark this as n, and this would be nothing but b of 3 of n. So this would be our answer. So just like that we can distribute our whole, the total number of teleports, we can reduce them into smaller powers of 2, which would be log n at max, because binary is binary form of any decimal number would have log n bits, right? So we in only log n transitions or log n smaller 2 to the power k steps we would reach the final value. So that's how we can solve this problem, right? Now how do we solve this problem? We apply the same logic. What we do is, if we calculate the sum for 2 to the power j times for 2 to the power j operations starting from ith node, it would be nothing but sum of j minus 1 starting from the ith node plus, so this is from I we did 2 to the power j minus 1 jumps, so all the nodes that we had in the way, sum of those nodes plus, now this is some node, so sum of j minus 1 from this node as well, 2 to the power j minus 1, so this 2 to the power j. And also this concept is known as binary lifting. This is a little advanced concept. So if you guys did not understand, I did not cover it like in very depth in this PCT. So you guys can go and check this out on any website or YouTube, anywhere you want. I think CP Algorithms has this pretty good. So you can check this algorithm out, binary lifting. This is what this is basically. This is binary lifting. So binary lifting is algorithm. I'll just write a description here. Binary lifting. We can find kth parent of a node in log n complexity. So we can find the kth parent like this. So again, since in this problem we need to find the sum of all nodes in the path, right? So what we can do is we can try to use the same concept. So from I we find the sum, we are trying to find the sum till 2 to the power j steps, right? So I till 2 to the power j steps would be I till 2 to the power j minus 1 steps, and then from node till 2 to the power j minus 1 steps. So now we need to know this node, right, to complete this equation. So node would be nothing but what we previously saw. Node is nothing but b of j minus 1 I, what we saw in binary lifting, b of j minus 1 I. So we can use these two relations. We can use this relation to fill the values for each sum, to calculate the values for each sum, so I'll write the equation here again. Let me, sum of j I would be nothing but sum of j minus 1 I plus sum of j minus 1 from node, where node is b of j minus 1 I, and for b we can write j I is equal to b of j minus 1 I, j minus 1 of b of j minus 1 I, and initial base values would be b of 0 of I is equal to ai, and for sum of 0 of I would be I. Since if I am making just one move, so since initially my ith bucket would be with ith person, so he will fill I liters only. So sum of 0 I would be I, and then I can just run the for loop like this for j is equal to 0, j less than equal to 32, j plus plus, and I'll just put my transitions here. So that would help me calculate the values, and then when I need to answer a query of t comma b, what I can do is I can check for each bit in t. So if t and 1 to the power some bit b. So if this bit is present in t, what I will do is I will add the value of sum of I whatever j, actually b, this b will confuse you. So let me do this as some bit, let me write this bit. So sum of bit from wherever the node I was on. So current denotes the node I am currently on, and initially current would be at b, actually this b. Don't confuse it with this array. Actually in code I have given this some other variable. Don't confuse. This b array is for binary lifting and this b is the query bucket. So it would be initially, the bucket would be at the bth node, and then what I can do is I can make the jumps according to the binary of t. So current from whatever current node I am on, I will do 2 to the power bit jumps, and I would add the answer, add it in the answer, and also I would need to update my current. So current would become b of bit of current. So from current I will make 2 to the power bit jumps to end up at the new current. So I can use this small logic to get the answer and see out answer. And since binary will have log n bits, so this for loop would be log n. So I'll show you guys the code. D. So first I take input the vector a, and this is just for making it 0 based. So lift is the same as this b, which would tell me the kth parent, and this next is the something. So sorry, this lift is the something and this next is the kth parent. I am sorry. So for lift of 0 comma I will be storing I plus 1. So lift of 0 comma I, this was for 1 based, and since I have made all my AIs as 0 based, so I will just do I plus 1 here so that the value is correct. And next of 0i is ai, so b of 0i is ai, and what I'll do is I'll run this for loop to fill up the values. So next of I comma j would be next of I minus 1 from next of I minus 1 j. So just like this, b of ji is b of j minus 1, b of j minus 1 I. Okay. So I and j are interchanged, don't get confused. Still the first index is the bit and the second index is the node. So from this node 2 to the power j minus 1 jumps. So 2 to the power I minus 1 jumps from this node. So basically from jth node I will perform 2 to the power I minus 1 jumps, and now from this node I will again perform 2 to the power I minus 1 jumps to calculate the value of from jth node of 2 to the power I jumps. And similarly for sum also, from jth node to get the sum till of 2 to the power I jumps, what I will do is from jth node 2 to the power I minus 1 jumps, and then from the next node again 2 to the power I minus 1 jumps. And then for the test case, I will see for all the bits in t, so starting from the 38 bit to 0 bit, if that bit is in t, then I can just actually this is not important, I will just add the sum in answer and I will update update the person who has the bucket. So b becomes next of ib and answer plus equal to lift of ib, and then see out answer. So overall time complexity per query would be log n, which would be well within the time limit. So that was the solution for problem E, and that was it for this discussion. So thank you.